Hey guys, welcome back. Mr. Marone here. Welcome into lesson 8.5, which is our last lesson in chapter 8, which is all about right triangles and trigonometry. Here we're going to look at real world problems and why we do what we do in regards to trig. They're very, very useful. They're super applicable. They're used very often, and it's something that's worth looking into. So when we do that, we end up running into two terms that are new. We don't just refer to angles as angles when we deal with it in the real world. The angles are either pushing stuff up or pushing stuff down. So we have terms for that. Before we go anywhere, you've got steps right at the very top to how to solve every one of these application problems. Right? The first thing you're going to do is pull out the given parts of a triangle that they're talking about. You're going to draw and label the right triangle, and then you're just going to solve like we've done. So it's really just adding an extra step. We have to just pull the stuff out of the question we're on. So the first thing we're going to talk about is the first of two terms when we refer to the angles. If I am standing at a place and looking up at something, my eyes have to elevate. So that is our angle of elevation. And the angle of elevation is formed by the line of sight, where your eyes are going, with where they are on a horizontal line in comparison with the ground. So if you were to draw a horizontal line to the figure you are looking at, that's your other line that we're going to use to create our angle of elevation, which is between those two. So anytime you're looking up at something, it's an angle of elevation. And that angle of elevation, as we use our theta, sits right there. So if we look at this example, they tell us that we've got a lighthouse, so we can kind of use our picture up here. Or we can just draw a picture. So here's my lighthouse. Terrible picture, but we're going to work with it. And it says that the lighthouse is 84 feet tall. Okay, and it says that Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. So we've got our little stick figure down here. Let me try that again. There's Casey, and he's looking at this lighthouse. He's looking up at the top of the lighthouse, and they tell us that it's 58 degrees. So there's my right triangle right there. They tell us that Casey himself is 6 feet tall. So that means that this distance in here is 84 minus 6, or it's 78 degrees. And they want to know how far is he standing from the base of the lighthouse. So in other words, what is this distance right here? Okay, so it takes some interpreting. Obviously my drawing ability is terrible, but I was able to pull the information out of the description. Looking at this, I've got the lighthouse. I'll switch colors here so we can see it. The lighthouse is my opposite side, straight across from my angle of elevation. Here's my hypotenuse, and then here's my adjacent side. So I've got information at opposite and adjacent, which tells me I'm going to use tangent. So it's going to be the tangent of 58 degrees, and that's going to equal my opposite side 78 over my adjacent side x. And if you remember from our previous video, whenever x is in the denominator, we can just swap these values. It's 2 steps of algebra, but we know the process, and the process doesn't change here. So I've got x equals 78 over the tangent of 58 degrees. And now we just go to the calculator. So I've got 78 divided by the tangent of 58 degrees. And I end up with 48.74. And in this case, they were talking in feet. So this is 48.74 feet. So he is that distance away from my lighthouse. Now, one thing you're probably asking is why I got this 78. If we know that Casey is 6 feet tall, that means that we have to take away 6 feet from the lighthouse in order for us to have the right triangle. In other words, this side of our right triangle is the whole length of 84 minus his height. So just keep that in mind, that can be a factor in your problems. Okay. For this one here, for example 2, we're going to set up our picture. So it says a dog is standing 5 feet from the base of a tree. So my dog, I'm not even going to try to draw a dog. I'm just going to put a little circle there. He is 5 feet from the base of a tree. There's my tree. And it says, looking up at a cat that has climbed 16 feet up the tree. So this value here is 16. And he wants to know, what is the angle of elevation? Ooh, this is something we haven't done yet. So let's set up our problem. We've got our reference angle. We know that I've got, switching colors, I've got my opposite side here, I've got my hypotenuse, and I've got my adjacent side. So they gave me my two side lengths, opposite and adjacent, so I'm going to use tangent. So it's tangent of the angle, which we don't know, theta, and that equals my opposite side 16 over my adjacent side 5. Now, whenever we do any sort of algebra, if I have 2x equals 4, in order to solve that, I have to divide by 2. You guys have done that. It's like the oldest problem in the book. Well, what you're doing is you've got 2 times x here. And in order to get rid of the multiplication, we have to divide, which is also known as the inverse. So we're doing the inverse operation there when we divide instead of multiply. Well, all of our ratios have an inverse as well. If you look on your calculator above each of those buttons, they have these little things with a little -1 in the top corner. That's the inverse for each of these ratios. -1 is the accepted number for inverse. So the tan -1 and taking the inverse of it really ends up just giving me theta on the left, and then I'm going to have my inverse tangent, tan -1, of 16 over 5. And all you have to do is plug into the calculator there. So it's the second button, then your ratio, and you do 16 divided by 5, and you end up with your theta is 72.65 degrees. So it's a little different process. You're using this inverse operation here to help solve it. So let's take a look now at our other type, which is the angle of depression. These are a little bit more difficult because of the way it's set up. So the angle of depression is if I'm looking out on the horizon and I look down, that's where the angle is. So if you're looking in this picture, notice where the angle is. It's not inside of our triangle, it's outside of it. What helps for us though is that these straight lines are parallel to each other. So I've got parallel lines being cut by a transversal. That allows me to use opposite or alternate interior angles and put my angle down here. They're the same thing, so keep that in mind, that you've got alternate interior angles that allows us to put the angle inside the figure. So even though my angle of depression is up here, for our triangle it has to go down in the bottom here. We cannot put it here. That doesn't work. That's not the angle of depression. So using that example, it says lifeguard sitting on a platform and looking down at a swimmer in the water. It says if the lifeguard's line of sight, we'll use the picture up here, is 8 feet above the ground, and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So I'm going to say this is X right there. So first thing I can do is move this 18 inside the figure. Now I've got my opposite side, I've got my hypotenuse, I've got my adjacent side, and so I've got info at opposite and at hypotenuse, which tells me it's going to be sine. So I have sine of my angle of depression, 18, equals my opposite side, 8, over my hypotenuse, x. We're going to swap those positions, and we have x equals 8 over sine of 18. And going to the calculator, 8 divided by sine of 18 is going to tell me that the lifeguard is approximately 25.89 feet from the swimmer, about 26 feet. So these are two more examples that we will do the first of, and then the second one will be there when you come back in. And I want you to try example 5 completely on your own. So I'll set up 4 and then let you solve it, and then 5 I'm leaving completely on your own so that you can come back in and see it. So it tells me this first building in this example 4 is 480 feet tall. And it says building 2 is 654 feet tall. And it says the angle of depression from building B down to building A, so this angle right here, is 42 degrees. And they want to know how far apart are the buildings. They want that value. So to figure this out, we have a little bit of work to do. My angle of depression can come inside here. And then I've got to figure out the difference here. I don't know what this value is, but I know that the bigger building is 654 feet, and I've already moved 480 feet up for the first building. So that tells me this is 174. So that's your picture to work with. Go ahead and try example 4, and then go ahead and try example 5 totally on your own and see how you do. Okay, welcome back in. So in the first thing, I set up the equation. I had a tangent here when I labeled it all out, and I had tangent of 42 equals 174 over x. I did my swap and plugged into my calculator, and I got 193.25 feet. Now in the second picture, it's a little bit different. Pete, our guy here, is standing on the top of the ocean bluff, and he's looking down in both directions. So we have two triangles to set up here. He had the same height, he's 6 feet above the ground, and he had two different angles of depression. He had 34 and he had 48. And so he was looking for the distance between the dogs. So we had to solve them separately and then combine them at the back end. And it was the exact same process for both. We were given tangent ratios for each, just with different angle measures. And I got 8.9 for one dog, and I got 5.4 from the base of this bluff. The distance between them is just combining the 8.9 and the 5.4. So the dogs are 14.3 feet apart. These are tough to draw. So as you can see from all of these, they're not easy. It's really just a lot of pulling information out of a picture. Be sure to take your time, and it really might even help to underline things as you're going. All right, make sure that that you guys are trying these, taking a look at them, bring in any questions you may have, and we will take a look then. Have a great day, guys. Bye-bye.